This video is going to talk about changing attributes of a prism and how the volume and surface area are affected by it. Attribute just means a measurement of the prisms. And this is only when changing one measurement at a time. We're only changing the length, the width, or the height, not all of them or two of them at once. So this first one, we have a 1 by 1 by 1 cube. If you look down here, you've got a one length and then one width and one height. It could be inches, centimeters, feet, doesn't matter, we're just calling it units right now. So the number of cubes, which is also thought of as the volume, right now we have just one cube, so it's a volume of 1. And then if you do length times width times height, you get 1. Now the number of squares is the surface area. I currently see one square in the front, one square on the side, and one square in the top. Now, hopefully you realize that those aren't all the faces that exist. There's actually a front face and another back face, and then a top and bottom face, and then a side and another side face. So we see 3 of the faces, but there's also 3 that we don't see. So that's a total of 6 faces. Now what we're going to do is find out what happens when we increase the height by a scale factor of 2. Scale factor of 2 is a fancy way of just saying double the height. So we have our figure here. We're going to double the height. So I'm just basically putting another cube on top of it. So now we have, instead of a 1 by 1 by 1, we have a 1 by 1 by, well, when we put these two units together, we now have dimensions of 1 by 1 by 2. So our number of cubes now has increased. We have now 2 cubes. The number of squares, we currently see 1, 2, 3, 4, 5 squares in this picture. That means there's 5 that we don't see as well. So that means we have a total surface area of 10. So when you double the height, the volume is also going to double. Now with surface area, when you doubled your height, the surface area did not double. It increased, but it didn't double. Just be aware that when you double the height, the volume also doubles. Surface area increases, but not doubled. Let's look at another one. We're going to take the shape that we had. We had that 1 by 1 by 2. Currently there are 2 cubes, and like before, we still have a surface area of 10. Now what we're going to do is increase the length of this figure by a scale factor of 3. Scale factor of 3 basically means you're tripling the length. It's a fancy way of saying it. So if you look at the picture, we have our length originally as 1. I'm going to be tripling that. That means I'm going to be sticking 2 more sets of blocks onto it. So we now have our new dimensions. It was 1 by 1 by 2. Our new dimensions, when we put those 3 units together, is a 3 by 1 by 2. So I've increased my length by a scale factor of 3. The total number of cubes now has increased. We have a total of 6 cubes. When we start talking about the number of squares covering this figure, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 squares covering the front side of this. There's also 11 that we don't see. So we have a total of 22 squares covering this object. So we need to tune into this volume again. When you triple the length, the volume also triples. We take our volume and we triple it. Did the surface area triple? If the surface area tripled, the new surface area would be 30. So it didn't triple, but it did increase. The main terminology you need to understand here is how scale factor, changing the scale factor of one of the measurements affects the volume and how it affects the surface area. So now we have this figure. Its current dimensions are 4 by 2 by 3. Your length is 4, your width is 2, your height is 3. So the total number of cubes here, you could count them. Or you could just use the old formula for volume. 4 times 2 times 3 is going to give you 24. You could also say that this first chunk of blocks here, there's 1, 2, 3, 4, 5, 6 blocks. And then, hey, 6, 12, 18, 24. There's 4 rows of those 6 blocks. A few different ways to think about it. The number of squares, when you count all these squares in this picture covering the face, we have 6, 8, and 12. Double all those faces. That also goes back to your surface area formula. But you're going to double all those faces, and we have 52 faces. So now what we're going to do is decrease the width by a scale factor of 1/2. You could think of this as taking your width and dividing it by 2 or multiplying it by 1/2. So let's look at the picture here. Our width was 2. When we chop the width in half, we now have this. This is our new picture. So let's take a look at that again. So we have a width of 2 here, and basically we're chopping off that back section of blocks. So now it's a width of 1. Our length stayed the same, our height stayed the same. So let's count our dimensions now. We have a 4 by 1 by 3. 4 by 1 by 3. Notice again you chopped your width in half. All right, your total number of cubes now is 1, 2, 3, and then 3, 6, 9, 12. You have 12 blocks. Your number of squares, we have 1, 2, 3 squares here. We have 1, 2, 3, 4 squares here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares here. Add those up and double it. You're going to have 38 squares covering this figure. When you halved the width, the volume also was halved. You divided your volume by 2. Did we divide our 52, our old surface area, by 2? No. The surface area decreased, but not by half the amount. Just a different visual here. What happens when you change one measurement on a prism? We have our prism here. We don't have any numbers. We just have some lengths, widths, and heights. Now before, our length was up front and our width was to the side. Doesn't matter. If they tell you what they are, you use those. But all the numbers are interchangeable. So you got to just pay attention to what's being labeled as what. So if the height is changed by a scale factor of 2, that basically means you're doubling your height. So in the picture, I'm just stacking another box on the box I already had. So when you do that, the volume also doubles. So it holds twice as much as it used to. Surface area doesn't get doubled, but let's look at it the way it does change. So your surface area increases. Your top and bottom faces stay the same. This middle, what used to be the top face, is no longer a face because it's the inside of your new figure. So then the side faces, the front and back faces, those are doubled. And your left and right faces are also doubled. So not all the faces doubled. Your lateral faces doubled, but your top and bottom, your base faces, did not double. They stayed the same. All right, here's another one. We have our picture, we have width, length, and height. If you triple the width, so basically we're tacking on 2 more boxes, the volume triples. If you triple one of the measurements, all of the volume, it holds 3 times as much, so the volume triples. Once again, the surface area increases, but it doesn't triple. So your surface area increases. Here's how it increases. Your top and bottom faces triple. Those are your top and bottom faces. Your front and back faces triple. Those areas. But your side faces stay the same. You originally had the 2 faces here, but now you've got it here and over on the far left. All these internal faces that are side faces are connected. They're part of the inside of the figure. So what happens when you change one measurement on a prism? If the height is decreased by a scale factor of 1/2, the volume is cut in half. If you chopped this height in half, the volume holds half as much. The surface area is going to decrease. Here's how it's going to decrease. Your top and bottom faces will stay the same. This blue face up top was all the way up here, but now it's going down to here because the height was cut in half. Your front and back faces, the areas are halved. And there they are. Your left and right faces areas are halved. And there they are. So this last frame is going to talk about how mathematically things get affected. So if the width is doubled, you have your original volume. We're taking our width and doubling it. So that means width becomes 2 times the width. So we can think of it like this: length times 2 times the width times the height. And when you rewrite that, you can think of it as 2LWH. These are all factors being multiplied. I'm just sticking the 2 out front. This proves how if you double one of the measurements, you're just doubling the volume. When the width doubles, the volume doubles. But the surface area grows but doesn't double. Just remember that. You're set. That's about it. Hope this helps. Best of luck to you.